What if we want to solve for v final or v initial if we're given acceleration and time at neither one of the velocities? For example, we're given v initial and we'd like to find vf, or we're given vf and we want to find v initial. We will arrange the definition of acceleration to make a new formula. We start with the definition for acceleration, and we'd like vf minus vi alone on the left. And at the moment, we don't even see vf and vi, but we will in a second. Let's get delta v by itself. We have to undo the division by t, so we multiply both sides by t. In this case, the t cancels out, and we have at is equal to delta v. Now we just switch sides. That's rule 4. That's one of the easiest ones. And now it's time to put vf minus vi into the picture. Right? Delta v, change in velocity, is vf minus vi. And what are we trying to find here? Vf. So we'd like it all by itself, and we have to undo vf minus vi. We do that by adding vi to the left, and of course if we do it to the left, we have to do it to the right. And there's a reason we put it there and on the other side. It looks a lot prettier where it is. And let's see, vi plus vi is 0 on the left. So here's our final equation. Vf, v final, equals vi, which is v initial, plus at. On the last slide, I said we put vi here on the left because it looked prettier. Well, it does. And this is such an important equation, it has its own name. This is the first kinematics equation. There will be 2 more, but this is the first one. And you know what? Let me get rid of that circle so you can see it in all its beauty. And what we have, if you have an initial velocity, which is the vi here, and then you accelerate for a certain period of time, you add those 2 numbers and you find your velocity at that new time. So we'll use this formula with acceleration, time, and the initial velocity to calculate the final velocity. But what if we have the final velocity but want to solve for the initial velocity? It's just a variation on the first kinematics equation. So we start here, that's our first kinematics equation, and we like vi all by itself on the left. So the first thing we do is just switch left and right sides. So we now have vi on the left, but it also has at. It's added to at. So to undo that operation, we will subtract at from both sides. So this cancels this, and we now have v initial is v final minus at. So we're actually going backwards in time there, right? Trying to find the initial velocity after it's traveled for a certain period of time. Let's step through a problem now to solve for vf. We have a car with an initial velocity of 3 meters per second. Here, that's v initial. Acceleration, 4.5 meters per second squared. And then for a time period of 8 seconds. And we'd like to find vf. We sketch it out here in the diagram. Here's our car, starts at 3 meters per second, accelerates, and we want to know the final velocity after 8 seconds. We will use the first kinematics equation. This is nice this time. We've already rearranged it to have vf on the left side, the first kinematics equation. No manipulation required. So we have our equation here. We substitute in initial velocity, acceleration, and time. And see how the units work? Second cancels out with second squared, so you have meters per second plus meters per second. And our answer, after you do the multiplying and adding, is 39 meters per second.